Good morning, everybody. Happy Monday. Hope you're doing well. All right. There we go. We're in week 10, folks. Look at that. 10 out of 17, I guess, but we're getting there as we got that little hanging Monday. How'd everything go? Hopefully the midterm went well. Not had a chance to look at those yet. Having a rough time, but that's okay. We'll get caught back up. So hopefully over this week I'll be getting those midterms done for you. Then I get caught back up with the projects as well. So it's just been one of those days. So. All right, we have a couple things on schedule today. First is coffee. Lots of coffee. Enjoy your coffee. Good morning. All right, so we're going to start into chapter 6. This is our first look at classes. And we're almost done with topics, believe it or not. Classes, arrays, a little bit of inheritance. We just touch on it briefly, and then we start building our graphical user interface applications. Hydration. Thank you so much, Fallen. Yeah, coffee's hydration. I'm gonna have to make another pot already soon. I do love this mug though. This one is like ginormous compared to the smaller mugs, so that is good. All right, let me grab this up here. And then don't forget, we've got one more week here for that project 3 coming up. That'll be due, right? So we're on our last week for that one. Alrighty. All right, I think things went reasonably well with the midterm. I think only a couple people out of the 100 students or so that I have had technology trouble, so that was pretty pleasant. I always worry about doing these things remotely because, you know, if something's going to break, it's going to be at the worst possible time. So hopefully that went pretty smooth. No, only one panicked phone call, that's pretty good. So I know this technology stuff gets a little crazy sometimes. All right, so we're going to talk about classes. This is one of the fundamentals of object-oriented programming, is using classes. And we've actually been using them without really knowing too much about it so far. And that's okay, right? The beauty of this is that classes are written in such a way that we get to use them and we don't really care about the details very much. So we're going to take a look at a couple common ones that we've done or we've used so far, and then we'll see if we can talk a little bit more about what classes are all about. All right. Come on, NetBeans. Let's go. So in Java, we have two terms kind of get thrown around a lot when we talk about classes. The first one, right, classes themselves. So classes are like the blueprint, the definition of these, and then an object is an instance of the class. So if you think of like tree, right? Tree is the definition, right? But if I say, hey, the maple tree over there, or the oak tree over there, or the pine tree, those are specific instances that I'm saying this particular tree. That's an object, right? So the object is the specific instance here. Close these down. And the class is the definition or the blueprint, or the, this is the general type that we're going to make instances out of. So let me start my new project. Oh boy, I'm in the totally wrong directory here. Documents, GitHub 1500. There we go. All right. Sweet. So one of the common classes we've used all throughout this so far has been scanner. We say scanner, we call ours keyboard equals new scanner given system.in. So right here, we see scanner is the class or the type. A lot of times we'll use those terms interchangeably as well. So the class or the type here is scanner. Our particular instance or our object here, we're going to call it keyboard. That's our variable name. That points to our particular instance, our object of this scanner. And the new keyword tells Java, make one of these in memory for us. And anytime we're dealing with classes, we're going to use this new keyword. Right? When we have primitive types, we just say like int number is 10. We don't use the new keyword. Right? We don't have to bother because that's a primitive type. But anytime we're dealing with classes, and our hint here is that it's a big capital letter as well. Classes should always have a capital letter for its name, versus our variables having lowercase ones. Come on, NetBeans. Help me out. Import. Right, so the class here is the type. This is our variable name for it. It makes a new one. And you can have more than one scanner if you want. I don't recommend it in this case, but that's okay. You could if you wanted. At least not dealing with the system in, right? Dealing with our file input and output, we'll make another scanner for reading files. Remember, we did that as well. So we had scanner, like our file reader equals a new scanner. And we would give it a file, right? File, test file, equals a new file, test.txt. Right, and we can hand it our file. Yes, import. Import file. And yes, file throws file not found exception. We might crash if we don't have a test.txt. That's okay, just pass the buck. Right, so in this case, we had two different instances of scanner. We had two different objects. Both the scanner class here, but just different instances. So things about objects and classes. Right? The idea with a class is that it's this kind of a self-contained package, right? And it has attributes or fields, all the pieces of data about itself, and then it has methods. Methods are the ways that we interact with it. So if we were to say keyboard dot, we get all of these cool things here, right? Everything here with parentheses are methods. Right? These are all things, ways that we can interact with this class. These are all public methods of the class. So this is all the functionality. These are all the things that it can do. Okay? We've been using some of these, not very many of them, but we use, next line mostly. It's like the most common one here. But there's some other things we can do, but we're not, again, we don't need all those features right now. File, right? Same thing, right? File has a bunch of methods. So test file dot, and we get to see all the things file can do. These are all the methods associated with the file class. Okay. We've used them before, right? We've used random, we've used scanner, print writer, those sorts of things. So what we have to do is we tell Java to make these objects in memory, create instances of the class in memory. That's what our new keyword does here. And then we can interact with them, right? The class tells Java how to build these things, and then when they get created, they each get their own set of attributes, which are unique. Right, so this scanner here knows that it works with system_in. This scanner here knows that it works with the file. So it has distinct separate sets of these things in memory that it creates. All these instances are separate in memory. All right, let's see. So if we wanted to write our own class, right, and that's the next level we're going to take this. So first we just looked at our code goes top to bottom, right? Line by line by line by line by line. And I said, oh, well, we could do an if or an else if. So we do this chunk, or maybe this chunk or this chunk, or the else ifs. And they said, well, also we could loop. We're going to repeat this block of code, come back up the top. Should I run it again? Should I run it again? And keep on going, repeating. And they said, oh, well, we could do methods. Sure, we could take this chunk of functionality and put it over in a method so I can call it by name. Hey, go do the method. Like jumped over here, go do this method. Jumped over here, go do this method. We've been kind of expanding what we can do with our code. Classes is the next step. Now Java is very particular about classes. So you'll notice we've in all of our files we had this thing called public class, and it had a name. Right? Every time we've been doing something, this has been here. We've never had to worry about it before. Right? Pretty much everything else we did was inside of public static void main, or maybe methods then that we wrote inside of these set of curly braces. Public class something, right? It's all happened in one class, right? So I don't know if you've noticed this one much before, but it's been there, right? So in Java, the name of the class has to match the name of the file exactly. Capital letter for capital letter. Okay? So chapter 6.java has the public class chapter 6. So Java has a rule that there's one class per file, or one public class per file. So I can make a new Java class file here. We'll call this one rectangle. This is an easy one to follow through. Okay, and again, I'm just going to take out some of this nonsense here. And all we get is public class rectangle in this package. Right? They all belong in a package. A package is just a folder in Java. Don't worry too much about that. Okay? So I can start writing my class here. And then what we do is now we can put some stuff in here. So usually the first thing we have is our list of attributes. And then we have methods. That's usually the format. Again, some people have different formats. Some people like attributes at the bottom. Some people like, it doesn't matter, right? Whichever way your organization, when you go out into the real world, does it, just follow along. It doesn't hurt anything, right? It's just a convention. I like putting attributes at the top. Some people like them at the bottom. I don't really care. So either way is okay. So when we're writing a class, right, this is the definition, the blueprint for how the class is going to work here. All of these attributes are things about the class that this particular instance of the class should know about itself. Right? So when we think about designing classes and writing code and solving problems, right? What we typically do is we say, okay, well, when I'm saying what my problem is, anything that's a noun is a potential class, because that's a thing, right? This object-oriented programming is all about how we work with code as objects. And it works out really well. Remember, code is for people, right? The code exists for people to read it. And it's also nice that Java can understand it, but we want to write our code so it's understandable and readable by people, because that's who we're working with, and that's who has to maintain our code and all of that. So with object-oriented programming, we write objects because that's kind of what we're used to in the real world. Right? Like we're used to dealing with, okay, I know there's this thing called a chair, and I know what my chair looks like. I know it, and you could describe your chair. You could tell me what color it is. You could tell me how many wheels it has. You could tell me what kind of material it's made out of. You could tell me whether or not it has arms. You know, all those sorts of things that make up a chair. Right? Those are all attributes of chair. Those could all be attributes of our class here, depending on what we need to be storing. So a class will kind of take all the details about a noun. All of its attributes become, we'll call these instance variables. They belong to each instance of rectangle, or each instance of chair, or each instance of cup or mug will have its own set of variables. Right? And every time we make one in memory, we get to store all of those variables for each one of them, because that's what makes them unique. And that's how we know which one that is. So a rectangle is boring, right? There's not too many things we know about rectangles. Like rectangles kind of have like a length and a width. Maybe they have, I don't know, like if you want to have a color, or sure. That's not, you know, whatever we need to store about this, whatever pieces of information we need, we're going to put as attributes. And you'll notice we have this public keyword here. So public means anybody can come and find this rectangle class and use it. Right? When we talked about methods, one of the great things about methods, and not the only reason to use them, but one of the great reasons was they were reusable. Same thing goes with classes, right? I'm going to make a class, and I want it to be reusable. I want to be able to use this object in many places in my code. Right? Because I'm going to write amazing code, it's going to be great. I'm going to take this class and reuse it. So it's public, so people can get at it. But what we want to do with our attributes is we want to make them private. We don't want people to access our attributes directly. There's this idea called encapsulation. What we do when we write classes is we're going to take all the details about ourselves. We're going to encapsulate them into a single class. Right? So rectangle has all of its attributes, or tree has all of its attributes, mug has all of its attributes. We bundle all that together into a single class here, so we can work with it as an object. And then we hide away all of our details. So all the things that make us our class, all of our details, we're going to hide away. We're going to call them private. We're going to say you can't touch them directly, because one of the things the class is supposed to do is maintain its integrity. Make sure that is only, or that no one puts it in a bad state. So we're going to say, hey, I have a private int for length and a private int for width. Then what I can do is I'm going to write public methods. Right? So you notice when we had like test file dot, these are all the methods of the file class. Dot. There we go. These are all methods that we can execute. Right? These are all public methods. These are ways that we can interact with it. So what we do with this idea of encapsulation, we're hiding all of our details away, and we're going to expose them with public methods. So I'm going to say public here. Right, so these are almost always private. And we're going to include public methods for people to interact with our class. So we'll say, okay, well, what kind of method do we want to write here? Well, I might write a method that returns an integer, and we'll call it getLength. And what we can do is we can return length. And I might have a public int getWidth that returns the width. Right, so I have public methods here that can get the length and get the width. You don't access length and width directly, because if you have access to them directly, you can change them. If I'm returning values here, remember we talked about when we return integer values, these primitive types, we're returning them, we're passing by value here. So I'm giving you a copy of length and a copy of width. Here, you're not actually getting direct access to my length and width, because then you'd be able to change them. Okay, so these are get methods. So a lot of times we'll have get methods to give access to our attributes, so people can see what the value of our attributes are. Okay, now if we want someone to be able to change the length and width of our rectangle, we could do that. So these are get methods or accessor methods. We also have mutator or set methods. So these are typically void methods. We might have a set length. And now set length, if you need to set the length, you probably need to tell me what the length is. Right? Let me format that a little bit real quick. So if you want to set the length of my rectangle, so you can make a rectangle and then you can set the length, or you could get the length here. Now, remember I talked about that classes should maintain their integrity and make sure that they're always in a good state. That's this idea. We're encapsulating all of our details. We're hiding away our attributes with private attributes, exposing public methods for you to interact with the class. I want to make sure the length you gave me is good. So I'm going to say if my length is greater than 0. Great, I'm happy. Now you'll notice length here is purple and length here is white. So if I say length equals length, it'd help if I could spell right. Length. They're both white here. Right? So I'm saying, and it's even warning me, hey, you're assigning itself. I don't get this purple length here. This is the instance length. So there's a fun thing with classes, right? Where to reference your class level, your instance attribute, we say this dot length. Right? This means this instance here. So this instance's length. Now you'll notice it turned purple. So this instance length equals the length argument. Now, some people say this is bad form and we shouldn't use the same variable name. I think that's silly because this is easy enough to just do this. Sometimes it's easy to forget, so I can understand why you might be worried about that. What I don't encourage you to do is say L. And you definitely could do that. But the problem is, now L is a terrible variable name. L's meaningless. Right? Remember, we want good, meaningful variable names. So I always encourage you, use the full variable name. Right? And if you are doing this thing, this is called shadowing, where we have two variables of the same name. One as an argument, one as an attribute. That's okay. You just say this dot. No big deal. Right? And hopefully you'll notice that it was warning you that we're assigning it to itself. So you just got to be a little bit careful there. But this idea here, now we're going to check and make sure, we're going to ensure that you give me a valid length. If you don't give me a valid length, I'm just going to ignore you. Right? If you try and set my length to negative, I'm going to say, nope, that's impossible. Right? That does not fly here with our rectangle. Right? You have to give me a valid length. Right? So this is a set method or a mutator method. We are giving public access to change the value of length, but what we're doing is we're protecting the integrity of length. We're making sure we're validating that you gave me a good value. Because if you give me a negative value, then it's not a real rectangle, right? And we're going to have some trouble. I'm going to do the same thing for set width. If you give me an int for width, I'm going to check first if my width is greater than 0. I'm good to go, right? If it is, then my this width equals the width. Again, this width is my instance here, equals the width argument. Okay, so we haven't really done anything super interesting with this rectangle yet, but we have a way of storing some attributes, right? We've grouped these things together. We've encapsulated all the details of rectangle together into a class, and then we've given you public methods. Now the other piece here, one of those other core fundamentals of object-oriented programming is something we call abstraction. So we've done encapsulation, we're taking all of our details, private attributes here, and then abstraction is all about, we're just going to give you public methods. It kind of goes hand in hand here with encapsulation. The idea is that we don't actually know how file works or scanner works, right? The only thing we know is that we worked with it abstractly. And I know that sounds a little funny, but we don't need to know the details. We just know, hey, there's a public method that does something, like exists. If the file exists, let's go do this thing, right? Hey, then we can go read it. I don't know how this works, right? We could go look it up, sure, because Java's open source, or, certain flavors of it are. Sure. Right? We can use a public method here. We don't need to know the details, so we get to interact with our classes in this abstract manner. Same thing here. right? You don't need to know the details. I mean, it's not hard to guess how rectangle works here, but they don't need to know the details. They just need to know they interact with an abstract set of methods. Right? Here's a bunch of methods that they can interact with. All these public methods here, they can interact with. Now, you'll notice we don't have the static keyword. Right? That one's totally gone. We don't have static at all. Because what static means is it doesn't belong to an instance of a class. Don't worry too much about that. We'll talk more about it later. But notice these methods here in rectangle are not static. We've dropped all of that because they belong to an instance of rectangle here. So you need to have a rectangle to call them. So like this one, we've done integer here. Integer.parseInt given 10, like that. Integer is a class. ParseInt is a static method. I don't have to make a new integer and then call ParseInt using that new integer. Like scanner, I have to make a new scanner. Then I can use keyboard. I can use the instance to call methods here. Those are instance methods, right? Like test file here. .exist is an instance method. It works on this instance of file that we created in memory. With integer.parseInt, that's a static method. You don't need an instance of integer. We just say, hey, use this method here, this definition. So what that means when we write classes is instance methods that are not static have access to all the attributes. If it's a static method, we don't have access to these things. So we'll get to more of that later. Don't worry too much about it here. Well, let's see. What else could rectangle do? Right. Well, rectangle could probably calculate the area. Right. We could get area, and that's returns length times width. Right. So if you have a length and you have a width, you can get your area of a rectangle. So I can make some rectangles if I wanted. I'm going to dump all of this because we don't need any of these anymore. So we'll just say I want a rectangle, and we'll call this small rectangle equal to new rectangle. Remember this new rectangle. This is saying, hey, Java, I want to put one of these in memory. Right? I'm declaring the variable, and then I'm instantiating it. Right? We declare and we instantiate. Doesn't always have to happen on the same line, but I think a couple people got tripped up by that on the midterm, or some of the quizzes too. That you could declare it, and then you can instantiate it on a separate line. This says, make an instance of it. Hey, good morning, Biggie. Happy Monday. Okay. Then what I can do is I can say small rectangle dot, and I get all of the methods. Notice there's a couple extra things here. Don't worry too much about that. We'll talk more about it when we get to chapter 10. I want to say the inheritance chapter. I think that's 10. Yeah, that's why I've got like 3 alarms set, Biggie. Happens all the time. I'm actually very thankful I don't have to make the drive in, because then like if my alarm, my last alarm is like, hey, it's 9:55, don't forget to go start class. When that one goes off, I can just roll out of bed if I have to, if I'm not already up. But that means I get to drink yesterday's coffee. All right, so the methods here, you'll notice some of them are in bold. Those are the ones that we wrote here that belong to our class. Get area, get length, get width, set width. So let's set the length. So maybe 10 and small rectangle dot set width is, I don't know, maybe 5. So let's print out the area of our small rectangle. Small plus small rectangle, get area. Okay, so it should be 10 times 5, right? It should be 50. See if we get 50. Well, it's thinking hard about it here. Of course, of course. Let me go change my compile properties here. Right, and I can get rid of all these imports. We're not actually using those. Oh, and we don't need that one either. There we go. All right, just cleaning this up. Now let's give it a run. All right, so our area of our small rectangle is 50. Now we can make another instance if we want, right? That's the idea. I have a class. That's the blueprint. I can make as many of these as I want. Let's make a large rectangle. Why not? Equals new rectangle. Again, this new keyword tells Java make a new one in memory. And then we'll take our large rectangle. Oh, larg. Probably large, right? Large. Dot. Set length. I don't know, let's make this one like 20. And a large rectangle. Dot set width. We'll say, I don't know, maybe by 50. Sure, why not? Why not? We have our large rectangle. 20 times 50 should be a lot bigger. Set 1,000 zeros. Yeah, 10 with 2 extra zeros, that should be 1,000, right? Let's give that a run. Look at that. And then we get our large rectangle out. So you can make instances of it, right? So one common thing, and I'm glad Mr. Gaddis goes over this, is this thing called UML. Now, sure. There's really good programs that build this sort of stuff. Go take the software engineering class. I think we cover some of those good programs here. I'm just going to do just Microsoft Word. This is not designed for UML, but we make do, and typically most people have access to Word, right? Or you could even use your Google Docs or whatever if you need to, the online version here. All I'm going to do is I'm going to insert a table. I'm going to make a little 3x1 table here. Okay? So in my 3x1 table, I'm going to center this here. You get, let me zoom in, sorry. So you get class name here. So class name at the top, and then you get list of attributes here, and then you get list of methods here in the third section. This is what we'll call our UML. How do I get to my header? There we go. Cheap and easy UML. Via Word. Okay? So a UML diagram. So UML is our Unified Modeling Language. I should have said that first, sorry. It's kind of a standard for modeling all sorts of things. One of them being classes. You can use UML for all sorts of good stuff here. You might have done network diagrams with them, maybe. You could do database diagrams in UML, all sorts of good stuff. So you can write class diagrams here in UML as well. So you get class name, list of attributes, list of methods. So for our rectangle then, right? Let's put this in here. Let's do a 3x1. So we center this one here. We'll have rectangle is the class name, its attributes, and now you use minus for private. Here, let me add that little note in here. So minus for private, and then plus for public. So we'll have width, and then you use a colon, and then the attribute type, integer. I don't know why. I don't know who made these rules, but that's what we do. So we get the name, colon, type. So name, colon, type. Okay? Width, and it loves to try and auto format, which is really obnoxious. I never fight it because it doesn't matter all that much. Okay? So width and length for integers, and then methods. So we have a set length, and that takes a length colon integer, again backwards, and then colon void, right? We don't return anything here. So if you have arguments, you do the same thing, right? Name and type, and then what does the method return? Return type here. A set width, given a width, which is an integer. That's a void method. We have a get width or get length, which returns an integer. We have a get, oh my goodness, we have a get, no, come on, line up right. Get width, returns an integer, and then we have a get area, returns an integer. Okay? So yeah, why did those format the way they did? There we go. Undo automatic bullets. There we go. Okay. So we can see this was our minus for private, plus for public. These are public methods. Right? We have the return types, so name and type. So that is for arguments as well as our attribute list, name and type, and then return type of the methods. return type. So if we don't return anything, we just say we're void here. Okay. All right so far? Now, Mr. Gaddis is really good and goes through how you can do this thing called Javadoc. Javadoc is fantastic. Oh, hydration. Thank you so much, Biggie. Drink some more coffee here. I'm slowly starting to wake up. Slowly. So Javadoc is fantastic. Nothing wrong with it at all. I'm never going to ask you to do it. Right? I trust that you can figure that part out. It's awesome. It's good stuff, but I just don't care right now. Right? I want to focus on, can we write code? Right? If you need to write documentation, go for it. Write your Javadoc later. I trust you can figure that part out. Okay? All right. Yep, accessors, mutators, good. This idea of data hiding or private fields, yep, we're good. I'm making sure we're not skipping through anything here that's important. Okay. Now, interestingly, you might think we could here, there's something wrong with it, we could have a private int for area here. And we could calculate area instead of, or calculate and store it instead of calculating it every time. But the problem is, if we try and store area, anytime length or width changes, we'd have to change area, which is okay. Maybe that's one way to go about it here. We just need to be a little extra careful that the calculation here, what's stored, never gets stale, which isn't too bad, right? We'd have to change it in length and width, which is okay. We can do that. So let's just return area here. But now what we have to do is we have to calculate area in length and width. Right? So we can say area equals length times width. And then I'm going to copy paste, or this dot length, right? We need to make sure it happens inside this length and this width. Length and this width. Now, hopefully, you're feeling bad, right? Anytime we have the same code twice, we should feel bad about ourselves, right? That's our general rule of thumb here. Right, well, what you should do is we should turn that into a method. Okay, sure. Now, we don't need it to be a public method, right? So not all methods of classes have to be public. Some can be private. So private methods mean they belong to the class, but no one can access them outside of the class, which is okay. We call that a helper method. So private methods are typically considered helper methods. So I might have a private void calculate area. And that'll set area equals length times width. And then instead of actually doing that arithmetic twice, right, we can just call our method, our little helper method. Boom. Look at that. We can calculate area after we set length and set width here using our private helper method, and it sets length times width to area. Awesome. So just be careful, right? If this is an attribute, right? If this is an attribute, instead of calculating it every time, it might get stale. Right, stale quote. Right, sure. Like bread, right? Stale bread or something, sure. Okay. So either way is okay. You know, a lot of this might depend on how you'd expect it to be used, and that's totally up to us. If we think someone is going to be nuts here and calling area 50 times, then it's going to make sense for us to calculate it once and store it, because it'll be more efficient than having to actually make the computer do the arithmetic 50 times. And that's just sort of a judgment call. When we start scaling applications out and you start working with bigger and bigger and bigger and bigger programs and get into the real world where we have like enterprise level applications that get used all over the place at an organization, it gets to be a lot more important. Typically, we don't bother with any sort of performance related things until you get to the data structures course, which is all about performance. right? So just, either way is okay. I typically like to calculate things that are calculatable instead of storing them. That's just my rule of thumb until I need to. So either way is okay, right? This or return calculate area, right? And it's sort of silly to return another method. We can't even return that, can we? Yeah, that's okay. Or get area. Wow, that doesn't even look right. Area now, like all spelled out, just looks wrong now. I think I've seen the word too many times. Get area could just calculate it as well every time, but then we're losing that gain of saying, hey, I want to calculate it once and store it. So either way is okay. So before we were just returning length times width, right? Now we're going to return the calculated variable, the stored variable. Okay, just a thought there. So if we were to do that, then in our UML, we might add here, right, a minus for private. No. Calculate area at the void method. And then we would add another attribute here for area as an integer. Right? Totally up to us. Maybe it's there, maybe it's just a method. Either way we want to design, it's okay with us. Excuse me. Okay? How are you folks feeling so far? This is a new concept here. Totally new. All right. You guys are a quiet bunch. Quiet bunch of folks. That's okay. It's all right. All right. Awesome. Thanks, Dusty. Okay. The next thing that we can do with classes then, the next level, is something called a constructor. So you'll notice here we were saying new rectangle. We never wrote this a way of what happens when Java makes a new rectangle. Remember what we said? Well, it has to go make room for all these attributes. Right? Anytime we make a new instance, it has its own set of instance attributes. So let me pull up my whiteboard here. We don't need our tree here. Clear that. Okay. So if we were to make a rectangle, right, when we say new rectangle, right, Java says, oh, okay, let me go get some memory out here for length, width, and area. Let me go find a place to store these things in memory. So somewhere out in memory, Java puts a rectangle with room for length, width, and area. I don't know, like x27fa. I don't know, just making up a memory address. It lives somewhere. Right? That's where that lives. So if we were to print out our rectangle, out a small rectangle, and print out our large rectangle, we're going to get this really funny thing. So if you go to and print an instance of a class that we write, we get funny stuff. And that's where it lives in memory. Here, 6B884D57. This one lives at 38AF3868. It's pretty much meaningless, right? But it's saying, hey, it's a rectangle at this location in memory. Sure. At that location in memory now, we can store our length, our width, and our area. Right, so every time we make a new one, Java goes out and says, hey, give me space in memory, computer. Okay, so, this printing these things out is a little silly, but we can see we've got a bunch of these in memory. So what we could do if we wanted here, let's do that for fun. Let's say for int number 0, number is less than 100, number plus plus. We'll make a rectangle, new rectangle, equals a new rectangle. And I'll just print out our new rectangle, just for fun. And we should see 100 different memory locations. And every time we make one, Java is just going to ask for some more memory, and that's okay. Not a big deal. Look at that. We see these things are all over the place. 38, 77, 5b, 72, 33, 68, 3a, 19, 13, 2f. We don't really care, right? We just know Java puts them somewhere, and my computer's happy to give it some memory. Right? So we made a bunch of them. Cool. Right? Makes a bunch of rectangles. No big deal. So, but this way, when we create them here, we can actually control that if we want. That's called a constructor. So we can write a constructor method here. So constructors are special methods. Right? So we can say public. Now, with a constructor, there's no return type. It just matches the name of the class. So this is a constructor. Constructor, no return type. And that's how Java knows they're constructors, and that the name matches. Oops. Okay, so there's no return type. So a constructor's job is to give values to your attributes. 0, area 0. Right? The constructor's job is to give your attributes values. Right? Job is to construct the object. Right? How do we take this blueprint, the class definition, and make it into an instance? Well, to be an instance, all of our attributes need values. Now, these are default values. They're not great here, but that's okay. So now what we can do, I can put a breakpoint in, and I can run this in debug mode here. Let's run it in debug mode. And we're going to see when I call new rectangle here at line 7, let me pop that in there. There we go. Oh goodness. I want variables to be in the same tab. There we go. There. Okay, now my variables and output are in the same tab section. Okay, so I'm here at line 7. I can step into now, and now I'm in my rectangle constructor. I see this. Remember, this is my way of saying this is what my attribute is here. So my length, my width. Now, they're already 0. A funny thing about primitives is they default to 0. But that's okay. We're going to go give them default values anyway. A constructor's job is to give them values. We like that. So we'll set them all to 0. And then the constructor's done. And we're back. Now we have our small rectangle. Okay? So now I can see small rectangle, and I can pop small rectangle open, and I can see its length, width, and area. Right? I can see its attributes. When we call set length, I'm going to step into, it's going to go into the set length method. Right? Just like when we debug methods, it jumps into the method. I see the length argument is 10, and I see my this is the rectangle, currently 0. Now length becomes 10. Okay, and then we're going to calculate area. Well, area still stays at 0, right? Because 10 times 0 is still 0. And then we'll set the width. Now I have a length, a width, and I calculate my area is 50. Life is good so far. Okay, so before I had that constructor, right, let's, oops, what's the edit? This one here. Toggle comment, control slash. Let me comment it out. Let's see what happens with my breakpoint. I'm going to debug it again. Okay, I want to step into, here's rectangle, right? It goes to rectangle, and we're going to step, and that's it. Nothing, we don't see anything. So what happens, and this is kind of a fun thing here, is Java will generate a constructor for you if you don't have one. So if you don't write a constructor, it actually creates one for you. They're almost always bad. So it's always a good practice to make your own constructor. Now, again, this was fine. The default constructor just leaves everything as is. It doesn't give attributes at all. In our case, we were just setting them to 0, but they default to 0 anyway, which is okay. So that's not too big of a deal. Not the worst thing that could happen, right? But if we write the constructor, then it will run. Right? If we don't write one, we get a no argument constructor, a default constructor provided to us. Okay? So what we might want, though, is maybe we want to write a constructor that takes some arguments. So I could write a rectangle that takes an int for length and an int for width. Oops, that should be curly braces there, right? And then it should, now you might be tempted to say, okay, well, if you give me a length and width, let me set my this length to the length. Don't do this, right? Don't do that. Because remember, we have a set length method that already does our sanity checking. So all we need to do is we need to call set length, given the length. Right? We already know how to do this. So just ask ourselves to do it. Right? Say, oh, hey, go do the set length thing. Go do the set width thing, given the width. Right? Go do those things, please. Okay? I don't know what it's complaining about. Overrideable method call in constructor? No, that's fine. Okay? So when you create an instance of rectangle here, right? Like when we were doing, file, we gave it a name here. So we could give rectangle a length and a width here now, instead of having to call it here. So if you give rectangle a length and a width, when you create it with this constructor, great. We don't have to call sets. These are really nice, right? The idea here, if you create a parameterized constructor with parameters, constructor with parameters. Parameterized, I don't know. Parameterized? That's probably right. I'm sure. That's got to be a word, right? Okay? We can do that. So we can take a length and a width. Okay? So we got to add that to our UML here. So we'd have rectangle. That doesn't take any arguments. And then we have a rectangle that takes a length integer and a width integer. Now again, they don't have any return types, right? They're special. They are constructors. Okay, we know. Okay, so now let's take out ours, right? Remember we said Java used to make one for us, right? So we'll just write the one that's tricky, right? That takes some arguments. Now let's see if we can run this guy. Come on. Uh-oh. We've got an error now. Here at this line, rectangle, new rectangle equals rectangle, required int, found no arguments. Actual and formal argument lists different length. If you write a constructor, Java takes away the default constructor. It says, oh, you don't need me. So by writing a constructor that requires arguments, means that default constructor is gone. So we could add the default constructor back in if we wanted, right? I just commented out to prove that point. If you want to have a default constructor, great, write it. If you don't write one, right? Maybe you want to say, hey, people have to give me the length and width when they create my rectangle. That's perfectly fine, right? That's up to you. You can write your own or you don't have to. Either one's okay. Okay? So if you want a no argument constructor, great. Hey, another random guy. Happy Monday. Awesome. If you don't want a no argument constructor, that's fine. You don't have to. It's up to how your class should work. So in our case, sure, we can make a no argument one, and we can make a one that takes parameters. Either way is okay, because you can go set these later. Okay? Now, printing these out, I'm going to get rid of these ones here. And we don't need to print our memory addresses here. This was fine. This tells us our area, but what if we also wanted like the length and the width, right? I know it's silly because we just got them, but that's okay. So the length of our small rectangle small rectangle dot get length. All right, well, this is already getting tedious, right? Length and width of our small rectangle, get width. Okay. Now, I don't want to have to do all this again for large rectangle, right? I don't want to do that, right? Okay, so let's do something better. Let's write a method here. So inside of our chapter 6 code that has main here, we're going to write a method. Here, so this will be public. Now, these ones are still static, right? Because they belong inside of this where we're working with main. It can be a little confusing here, but like we don't have an instance of chapter 6. We're never saying, hey, here's a chapter 6 we're using. We just want this stuff to run. We just want main here. Okay? This is our print rectangle. That takes a rectangle, and we'll just call it rectangle. So if you hand this method a rectangle, we can go do something with it. Void, sorry. Public static void print rectangle. You give me a rectangle, I'll print it out. So I'm going to copy all of this here. And I don't know which one's which now, but that's okay. Now it's rectangle, get length, get width, get area. And then all I have to do is I have to call my method print rectangle given the small rectangle. And I can call print rectangle given the large rectangle. Okay, look at that. So I can pass classes around to methods. Instance of classes around to methods. Right? The length, the width, the area. Okay. All right, I got 11 o'clock. Why don't we take a quick break? You folks are doing great. This is a lot of stuff. Working with classes is a new way of thinking, right? We're totally changing up how we're writing code, how we're working with our code, dealing with our code. So it's a lot, don't worry. We're going to take some practice with it. Why don't we take a couple minutes? I'll throw some music on. We can take 10. I'm going to go refill my coffee cup. We can go from there, okay? All right, sounds good. We'll be back in a couple minutes. Hey, gang. Sorry, I was trying to wait for that coffee to finish. I just started my other pot here, and trying to get it to finish brewing. Alright. So, talking more about classes, right? We got our constructor here. Right, and you'll notice we have two of them, and that's okay. We have this overloaded constructor. So overloaded means there's more than one here, and that the arguments are different. Okay, if we wanted to, we could have another one here. Why not? So rectangle that just takes. Oh, we could. I don't know. We could change it to like double length and double width if we wanted to. A double length and a double width that does something. And so you can have multiple methods with the same name as long as the parameters are different here. Actually, we probably don't want one with doubles. That's fine. Unless we change everything to double. I guess we could, but this is probably okay. All right, so there's rectangle. Sorry, this is hot. All right. Let's see. Let me grab our slides here. Make sure we're not missing anything. Okay. All right, this is a silly example, but it's okay. So that idea, when you have more than one method with the same name, Java is going to look at the argument types. So if we have, let's call this void, I don't know, sum, int A, int B, and we'll print A plus B. And we can also have static void sum of string A and string B. Again, this is just a contrived example here. Print out A plus B. Now, two methods, same name, but their parameters are different. So one takes integers, one takes strings. This is just silly, but that's okay. So if we call sum here, in our main, that's good. We need to tell it, well, which one do we want? Well, if we give it 1 and 2, we'll get that one. If we give it 1 and 2, we'll get the string version. Right? So what Java does, it says, oh, you want the sum method that takes 2 integers. Great, I'll find the one that takes 2 integers. Oh, you want the sum version that takes 2 strings? I'll run the one that takes 2 strings. They call that binding. So the name of a method and its parameters is what's referred to as its signature. So Java says, oh, okay, I'm going to match the signature and I'll bind to that method. That's how Java knows how to do that. So with our rectangles, right, this one takes 2 integers, so it's going to bind to that constructor method that takes integers. With this one here, it takes no arguments, so it'll bind to the constructor that takes no arguments. So you're able to do that overloading thing, right? Right, so we can have more than one definition here, and Java will find the one based on which signatures match here. Okay? Let's see. Yeah, Mr. Gaddis says the shadowing thing is not encouraged. I disagree. I think shadowing is fantastic. But that's just me. That's okay. Don't worry about that. Okay. All right, yeah, we are working our way through the chapter. This is good. So there's another example, which is fun. So let's take a look at this one here. So let's write another class that Mr. Gaddis has. And what he gives us is essentially the UML. Right? And we have to go and figure out how to make these things work. So it's bank account is the example. Okay, and bank account has a bunch of attributes. Right? It has a double for balance. I'm going to add a string for name, or type, or something like that, like savings or checking or something like that, because I think that makes a little bit more sense here. Okay, so we're going to deviate a little bit from Mr. Gaddis' example, but that's okay. So I'll have a double for balance and a string for name. Now again, this is probably bad here. I would not recommend you actually write banking software with straight Java doubles. Remember, rounding gets really weird with doubles. Remember, like when we were doing arithmetic, Java's just dumb. Remember, I think we did this example a while back. We said double, I don't know, number is 0.0, and then for int, I don't know, times is 0 times is less than 100 times plus plus. Let's take number plus equals 1.0, and we'll print out number. Do you remember this? Did we do this before? And what happens? Come on, Java. Oh, that one's adding nicely. Okay, that didn't. Okay, let's try 1.5 or 1.25. We'll add 1 1/4 every time. See if we can make Java freak out. No, it's still behaving. Goodness. All right. Usually we can break it. Hang on. Let's see. What do we have to do here? Times equals 2. Is that it? Yeah, we'll just do that like 20 times. One of these ways will break it, I promise. We'll get there. Oh, probably start at 1. We'll get there. I'm trying to break double. Trying to prove a point here. Come on, Java. Nope, that's all happy. Okay, sure. How about 1.1? This ought to do it. Nope. Okay, it's cooperating. Usually you get some really weird decimal place hangers, and I don't know why it's not doing that right now. But that's okay. Just don't use doubles for banking. Don't know why is it behaving so nicely? I'm puzzled now. Number 2. This one do it? No. Okay. I don't know. It's not breaking. That's okay. Usually you get like all sorts of trailing decimal places. We did that before, didn't we? Okay, that's all right. Anyway, so we need some methods here. So we need a bank account constructor, right? The name matches the class name here, and I want a string for name here. So if you give me a name here, I'll set my this name to the name. Remember the purple ones here, great. And then I'll set my balance to 0. Right, I'm going to set defaults. The constructor's job is to set defaults. I'm also going to write a bank account constructor. Takes a string for name and a double for balance. So if you want to give me a balance initially, great. So this name is the name, and this balance is the balance. Okay, either one is okay. So if you want to give me a name and a balance, great. If you just want to give me a name, I'll start your balance off at 0. Okay, then we need some ways to interact. So what do we do with bank accounts? Well, we can deposit, and if you give me a double for the amount, great, we'll deposit. Now again, we want to make sure that we're being sane here. So I'm going to say if the amount is greater than 0, let's go do this deposit. Right? Don't deposit negative amounts. That's not a deposit, that's a withdrawal. I'll take my balance plus equals the amount. Great. We're just sanity checking it here. Now we also want to make this nice and easy here, so I'm going to write another method here, deposit, that takes a string for the amount. If you want to give me a string version of that, great, we can do that. So what I need to do is I need to turn it into a double. So my double amount, actual amount or something, sure, is double.parseDouble, given the amount. Then we can check if the actual amount is greater than 0. We'll go do our thing. Now again, I'm going to feel bad here like this, right? If I have the same code in here twice, balance plus equals amount, I should feel bad about myself. Actual amount here, right? Feel bad about myself because I have the same code twice, so don't do it, right? What we can do then is we just call deposit given the actual amount, right? Our method can call another method. Deposit here, right? Our method can call another method. And if that's all we're doing, well, really, we can just do this then, right in there. Just parse double the amount, hand it to the deposit that takes a double value. Easy. Right? This way, our logic only has to happen once. Right? Save yourself some time. Work smarter, not harder. We're going to do the same for withdraw. Now, withdraw a double amount. If you want to withdraw an amount, now, again, we still want to make sure that that is positive. Because if you withdraw a negative, you're really depositing, and we're just going to subtract that here. And we'll write a withdraw that takes a string for the amount. And we'll do the same thing. We'll just call withdraw given double.parse double given the amount. Okay, so I'm giving you public methods that can take a string or a double to make the class easier to use. I want my class to be friendly here. And then a double get balance. That just returns the balance. Okay, so you can interact with my bank account, but we probably also need a get name, right? So a public string get name, returns name. Nope, not balance, name. There we go. Okay, so you can get the balance, you can get the name, you can withdraw money, you can deposit money. Now, I'm going to avoid those set balance methods because I think that's probably wrong, right? You probably don't go to the bank and say, hey, set my balance to this, right? You would probably go to the bank and say, hey, can you deposit some money for me, right? We don't often just set the balance specifically. So I like going about this way here. Okay. Now what we have is we have a class and we know it should do some things, but remember, it's possible to have bugs in our code, right? Bugs where it does the wrong thing. We know what it's supposed to do, but maybe it does it wrong, right? So what we can do then is we can test it, right? Any code that's worth writing is worth testing. Right? Because if it's not worth writing, then sure, don't test it. But if it's worth writing, it's worth testing to make sure you did it the right way. Now, the only way we've tested stuff so far is to call it in main. I'm going to get rid of that sum thing because that was silly, but that's fine. Oh, sure, we'll leave it. We'll leave it. Why not? So we would say, hey, here's a bank account. I don't know, savings equals a new bank account. It would say here savings and I don't know, $100 to start, something like that. Sure, and then savings dot, and we would call savings dot. We could call deposit, we could call withdraw, we could call get balance, we could deposit some money, and then we would say, okay, so if I deposit another $100, then when I print out my savings dot get name plus balance plus savings dot get balance. We should say, okay, well, if I started with 100 and I added another 100, I should have 200 in there, because we know what to expect, right? And we're going to have to look at it and look at this output and see if it does what we expected it to do. All right, balance was 200. That's looking good so far. So we've checked, hey, can we deposit some money? Well, we should deposit, right, a string value. We could withdraw some money, those sorts of things. But doing this and having to look at the output is very failable, right? Turns out us humans we're bad at this sort of thing. Have you guys ever proofread your own English paper? Right? And you know what it's supposed to say, so you just kind of gloss over. So it's easy to miss something in checking the output here. So it turns out we have a better way. The better way is what I'm going to introduce and call unit testing. Okay? So NetBeans is fantastic at this. You can do unit testing with other IDEs. They almost all have a way to do it. I've not found a way to do it in JGrasp easily, but we're not using JGrasp, so that's okay. So what I'm going to do, I'm going to go to my bank account class, here. I'm going to right click on it and say navigate, go to test. Okay, so the class you want to test, we're going to right click on it, say navigate, go to test. That being says, oh, you want to create them? Yes, please create them. Now this part's important here. This JUnit framework, I don't know how it works. They changed a bunch of things. This is the latest and greatest version, and I can't get it to work. I tried like half an hour worth of Googling and gave up frustrated because almost all the answers said use JUnit 4. So sure, I'm just going to use JUnit 4. So when you write your tests, just pick JUnit 4 and life will be easy. All right, there's a way to get the newest, latest, and greatest version to work. I just don't know what it is right now, and I didn't want to put the time into it when all the things I found online said just use 4. So 4. Right, we don't need any of this generated code stuff here. Don't worry about any of that. Right, we can just leave all those unchecked, and we can just leave our method access levels checked here. These are all good. Okay, so JUnit 4, protected, public, package private, checked, everything else unchecked. We'll say OK. And NetBeans is going to make a whole new thing over here. So we've had over here on the left this test package for quite a while. We just never opened it. And now we have some code there. And I'm going to take these comments out. And the idea with a unit test is we're going to make Java do the checking for us. So we're going to test deposit. So what it does is it looks for every method and it writes a corresponding test method. Now, sometimes that's a little bit overkill. So don't worry too much about it here, but we want to test deposit with a double. We want to test deposit with a string. This is good. So in our unit testing, we do this thing. It's called the AAA convention. What that means is we're going to arrange our variables, we're going to act on our code, and then we're going to assert that we got the expected results. So this setup required variables for testing. Act is actually all the code we're testing. And then assert is, did we get what we expected? Okay, so just like what we did over here in main, we said, okay, I'm going to make a bank account, put $100 in, deposit another 100, I should get back 200. We do the exact same thing, but we're going to do it in code. So what I'm going to do is I'm going to have a double for initial balance. Initial balance, let's say was 100. We're going to have a double for expected balance, then was 200. Okay? Right, if I start with this and I add 100 more, I should end up with 200. So this is what I make. These are the variables I have. Everything should have a nice name. Right? Remember, all of our numbers should have names, right? Don't just use numbers in our code. So then we're going to make a bank account. Say bank account, test account equals a new bank account. Bank account. And the name doesn't matter here. So test name doesn't matter. That's okay. And then the initial balance. Okay, we give it an initial balance. Great, now we're going to deposit. So now we're going to take our test account, and we're going to deposit the initial balance again. Right, so if we start with 100, deposit 100 more, we should get out our expected balance. So then what we do is, I like making another variable here. Some people don't. I'm a fond of having variables. So I'm going to say a double for actual balance then is my test account. Get balance. This is what the code actually thinks we have, right? So this is what I expect to get. This is what the code actually thinks we have. And then I can assert that the equal. So I say assert equal. Now I have an expected balance and an actual balance. Now the problem is these are doubles and Java's bad at doubles. I couldn't prove it to you, but I promise Java's bad at doubles. So what we need to do is if we're comparing doubles, we need to tell Java how close is close enough. Like as long as they're within 1, I don't know, millionth or so of each other, this is fine. So this is comparing doubles, give a delta value. How close is close enough? So as long as they're within a millionth of each other, I'm going to tell Java, yeah, those are close enough. Because sometimes Java is really bad at doing arithmetic. I wasn't able to demonstrate it. I don't remember why. That's okay. We can figure that part out after later. Okay? Okay, so now I have in code here, it's going to check if I start with $100, deposit another 100, did I get out 200? And I can right click and I can say test. And then we get this really cool test output. Come on. Where we get a bunch of green check marks or red X's. Green check marks means we passed. Notice they all passed right now because they didn't. So if you don't fail, you pass. It's sort of like a Boolean. Either you failed or you passed. So if you didn't fail, you must have passed. So all those other tests passed because we didn't write anything yet. But this was good, right? So this is the AAA convention. We're going to set up all the variables, actually call the code we're testing, and then see, did we get what we expected? Okay, so we're going to do the exact same thing here for test deposit with a string. So this will be our deposit is, say, I don't know, let's just do 100 here. That's a string. So we'll just set up this constructor here that just takes a name, and then we'll deposit our deposit amount. We'll get the balance back out, and we'll say, hey, I should have 100. If I put 100 in, I should get 100 back out. I'll run this one. And you can just run file. If you're in the test, you can also run file. You don't have to click test. This is unit testing. So we're taking one small unit at a time, one method at a time, making sure it does what it's supposed to do. Okay, so that one passed. So our deposits are looking good so far. Now, you'll notice though, in bank account, so this part was running. Right? I want to make sure that this is going to work if I give it a negative value. Right? Because I want to make sure I'm testing all of the cases here. So I have an if. I want to make sure that the other case also happens. If this is not true, I want to make sure I don't deposit. So I'm going to do another test. So I'm going to copy all of this. And you need this at test. That's an annotation. You need that one there. Otherwise, Java gets confused when you test it. And what I'm going to do is I'm going to name it here. This is test deposit. Negative doesn't do anything. I don't know. Right? A nice, meaningful name. Here. So if we have an initial balance, and then our expected balance will be 100, and then our deposit then, a bad deposit, equals, I don't know, we'll say like negative 100. So if we give it a bad deposit, it shouldn't do anything. So if we start with 100, actually I can just get rid of this initial, oh, that's fine. We'll start with 100. If I try and deposit a negative amount, nothing should change, so our actual balance should still be 100. And I want to make sure that the code is working as expected, and that we're not actually depositing negative amounts, which is a withdrawal. Okay, and that one passed. So we have a good feeling that this is probably correct, right? And what we're doing here, this idea of testing all of these if, all the else branches here, is we're looking at this idea of what we'll call code coverage. When the unit test runs, if this line of code runs, then we have code coverage for that line. If this line of code doesn't run, then we don't have code coverage for it. So there's some fancy tools you can buy. There might even be a free one. I haven't found one that I like yet that was easy to set up to automatically measure this sort of thing. Because of course developers aren't going to do this by hand, right? Good programmers are lazy, so we're going to write a tool to do it for us. But we want to make sure that all of the code that we wrote is getting ran. So if we only ever used this constructor, I would not have 100% code coverage because these lines of code never ran while I was testing. That's why you'll notice, so this one I tested where I gave it a balance, this one I tested where I didn't give it a balance, because I wanted each constructor to run while I was doing my tests, right? This idea, I want to get towards 100% code coverage, so 100% of my code runs during my tests. That's the gold standard. That's ideal. Now, a lot of times that's hard to get to, and that's okay. There's no rule that says you have to have 100% code coverage or your software is terrible, right? The more unit test coverage we get, typically the better code we'll have because it sort of checks to make sure we're doing the right thing, right? It's ensuring we have quality code, right? Because we want to make sure that the code does what we expect it to do. So we're not guaranteed to be bug-free just because we have code coverage, because it's possible you screwed it up twice. Just like proofreading your paper. You wrote it once wrong and you proofed it wrong. We might have done the same thing. We might have tested it wrong as well, like tested for some inaccurate behavior, or we screwed up our test, or those sorts of things. So it's possible to screw up and not have bug-free code, even with 100% code coverage, but that is the goal, to get 100%. And when we're writing it, sure, it's easy. Out in the real world, that can be tricky, especially if you have existing code that didn't have unit tests. Right? Going and adding them in takes a lot of time, energy, and effort, but it's usually worth it. Right? But so what you get, like the gains you get out of unit tests, like if you're unit testing half your code, if you have like 50% code coverage, you're going to catch a lot of bugs, hopefully. If you get to like 80% code coverage, you're going to catch a couple more bugs possibly, but not quite as many as you might have caught getting to 50%. And going from 80% to 90% takes even more time, energy, and effort, and you're going to catch less bugs. So it's the idea that you have diminishing returns. So at some point, there's a business decision to say, oh, okay, well, unit tests are good, we like them, but it just is going to take too much time to get to 100% code coverage. And that's okay. We do make these business decisions, these trade-offs all the time. So like saying I need 100% code coverage is not the hill to die on. You don't have to say, no, it's this way or I quit. It's not worth it, right? There's a fine line there of, we definitely want unit tests, but some right amount of tests. Yeah. Bono Kazooie, definitely. Your test could be bad. You could have a silly test like, does true equal true? Or like ours, we never finished them, and we said, oh, yep, tests are passing. Life is good. So let's go do our other tests here. We're going to withdraw. So if you test a withdraw here, so if we have an initial balance, let's set the initial balance at 200, an expected balance of 100, and we're going to withdraw amount of 100. So we start with 200, we take 100 out, we should end up with 100. So start with 200, we withdraw the withdrawal amount, then our balance should be 100. So a lot of times these asserts are nice, like they just, sure, it's the same one, right? The actual balance is what we expected. We can copy paste pretty easily. This is working well, so let's copy this one then, we'll withdraw with the string. Then withdrawal amount is, quote, 100. Right? The rest of the test is the same. Right? Method's still the same, so we start at 200, take 100 out, we get that one. And we also want to try and withdraw a negative and have nothing happen. I'm going to copy all this. Withdraw negative, nothing happens. I don't know, or it doesn't work. I forget what we call the other one. That's okay. So if we try and withdraw a negative amount, then our balance should not change here. Right, so we withdraw negative, our balance should stay at 200. Okay, now getting balance as its own test to me is silly because we're already using it over here. So I'm going to skip the get balance tests because I don't need it. Sure, get name we haven't tried yet. So sure, we'll make a new one here. Okay. So sure, so we don't need any of this balance stuff. We just need a string for name equals test account name. Why not? Test account name. We'll give it the test account name. We don't need to withdraw anything. We have an actual name. Get name. Actually, so that should be the expected name. We have an actual name. And then does expected name match the actual name? Expected name match the actual name. And with that one, there's no delta, obviously, because strings. Okay, we'll run our tests. Right, they all passed. Life is good. So if I were to like mess one of these up here, just to show you that it fails here, I'm going to change my balance and run our tests. I want to show you the big red X. Those are nice. There we go. Oh, it's not even red. Yellow. Okay, yellow exclamation. Sure. Failed. Still a failure. Okay. It expected 300, but was 100. So we can see right here what happened. That was at line 125 here of our code is where it failed. We expected a 300, but we actually got a 100. So our actual balance was 100. We expected a 300. Right, because we typoed that. Sure. So we put that back. And then I can run it again. Where's my test page here? And you can also run individual tests from here. We can just say, oh, not go to source. Just run that one again. Run again. All right, so this idea of unit testing, we're going to be doing this on our next project, making Java do the checking for us. Because people checking in main, still good, right? Still good to test your code, but it's easy to make mistakes, right? And then it's hard to repeat it because every time we make a change, we have to run it again and look at all of our output. Now, anytime I change bank account, I just need to run my bank account tests, right? So maybe we add more features to bank account. Maybe we get like an interest. Maybe this is a savings account where you get a couple pennies, right, on your money that you have stashed away in the bank. Sure, we could add that to bank account, and then we can just keep running our tests to make sure we didn't break any of the other stuff. So unit tests are fantastic. Strongly recommend them. Definitely worth doing. But that 100% is not really a hill to die on. It's good, and it's usually easier to get to 100% when you're writing new code. So, and again, it depends on the organization. A lot of them might have a rule of thumb like, hey, anytime you're updating the code, you'll go and add some unit tests if they didn't exist already, because you're already in the code there. Sure. There's all sorts of ways organizations will go about it. But definitely good to have, worthwhile. And this is just at the unit level. So we're saying we're going to test one small method at a time at the unit level. There's other levels of testing we can do where we make sure does code work with other code. We're integrating testing, integration tests or end-to-end or system tests. Does the entire system itself work? That sort of thing. There's all sorts of testing. Go take the software engineering class. You'll learn more about it. All right. So we're about out of time today. We've got on Wednesday, we'll wrap up our first look at classes. We'll do a little more chatting about it. We'll do some more unit testing, practicing it. Do you folks have any questions about the project that's coming up due? Project 3. That one's coming up soon. Let's see. Project 3. Come on. Oh, I got to grade Project 2 still. Sorry, I had it was a rough weekend at home, so. Right. So, using methods. Lots and lots and lots of methods. I think we looked at having a bunch of methods already, right? I think I gave you like, hey, this is what your methods might look like. Check GitHub. 100. Enter. There we go. Let's find the right one here. Yeah, Project 3. I think I gave you some method ideas a while back. This is what your methods might look like. Right? Like ask for player create mode. Sure, play mode, create game introduction file, create command files, create a skateboard file. Like break all these down step by step by step, do that functional decomposition, solve one small problem at a time. And really, this is not repeatable. We're not going to create the skateboard file more than once, but we have a nice name for what's happening, and we've broken out that problem to solve into a smaller bit here. Okay, so we're going to take advantage of methods. All right, let's see. And I think, did I add the rubric for this one? Yes, I added the rubric for this one. Good. I'm behind on the rubric for the other class, so I'll add that for them. All right, any thoughts, questions, concerns? We all set then? Should we head out and visit someone else in Twitch land? Who else is around? Twitch. That's the wrong tab. Check it out over here. Let's see. Oh, I don't actually see a lot of people right now. Huh. Not a whole lot of people around online. So maybe no raid. Boring math professor's there. If you want to do more, well, let's go check out some more math. We like math. Tommy said hi. Oh, I think he's just ending. Oops, that's okay. It's good timing, right? All right, I've got office hours today, just for a little bit this afternoon. I've got them Tuesday, Wednesday, and just a little bit Thursday. So schedule an appointment, drop in if you guys want to chat, and we can go from there. Take care.